Hello everyone, welcome to my channel today. We want to talk about exam style questions on straight line graphs. Okay, I have about 16 questions here. I'll do as much as I can and then the rest you will do it. All right. I'll put a link to the questions in the description so you can check it out and then download the worksheet so that we can all work it together. So while I'm talking, while I'm solving, you will be solving alongside with me. All right. At this stage, if you haven't subscribed to the channel, please do so. And now let's start with the very first question. It says that the line this meets this particular curve at these 2 points. All right. Okay. So we should find the coordinate of the point where the perpendicular bisector of the line AB meets this particular line. Okay, so the point is that we are going to find the coordinate, okay, of the perpendicular bisector, the point of contact of the perpendicular bisector, and then this particular line, right? Okay, so if there's a perpendicular bisector of line AB, then this is how, let me help you with a pictorial view of what is happening. Right, so let's say this is A, this is B. If there's a perpendicular bisector, then that perpendicular line divides line AB into two equal parts. Okay, so this particular point here would have been the midpoint of that particular of these two lines. Okay, so let's call it midpoint P. All right, so now let's find the coordinates of the midpoint P because it's a perpendicular bisector, therefore we need that. So it will be, so the midpoint AB, midpoint of AB will be equal to, we sum the x values, which is -2 plus 4/5, we divide by 2, and then we sum the y values, -4 plus 10/2. All right, now what will happen is that we will get -3/5 here, and then this will be 3. Okay, all right, so we have the midpoints now. Now the next thing that we need is, you see, the question is talking about this perpendicular bisector meeting this particular line, so we need to find the equation of this line. So in order to find the equation of a line, you need a point, which is the midpoint that we have found, and then we also need a gradient of this line. But we do not know 2 points on this line to find a gradient, but we can find a gradient of line AB, and that would automatically help us to find the gradient of the perpendicular bisector. All right, so let's find gradient of line AB. So gradient of line AB would be equal to 10 minus 4, okay, over 4/5 minus 2, right? And if we put it on a calculator, that will be 14. Let me bring it back. That will be 14 over 4/5 plus 2. That will give us 5, right? Okay, so the gradient is 5. Now the gradient of the perpendicular bisector, so gradient of, I'll just do this to show perpendicular bisector, will be -1/5. Okay, so now we can form the equation of that line. So equation of a line is y equals mx plus c, okay, where m is the gradient. Now this gradient is -1/5 x plus c, so we need to find the c. All right, so in order to find this particular c, we are going to use this point. You need a point on the line, and this is the point that we are going to use. So y is 3, x is -3/5. All right, okay, so we are going to get 3 is equal to 3/25 plus c. All right, so this implies that c is equal to 3 minus 3/25, and then if I put it on a calculator, I'm going to get let's see, 3/25 That is 72 over 25. Okay, so now the equation of the perpendicular bisector is y is equal to negative 1 over 5x plus 72 over 25. All right, but this particular line meets this line. Okay, so now it means that we have two lines that we are going to solve simultaneously. Right, so solving these two simultaneously, we are going to get x will be equal to, I'm equating the y's, so we have this, all right, plus 72 over 25. So I'm going to have x plus, let me just do it, x over 5 is equal to 72 over 25. All right, and that will give us 6. X over 5 is equal to 72 over 25. So I can cross multiply if I want, yeah, or I can just multiply it by 5. So 72 over 25 times 5 will be 72 over 25 times 5. That should give us 72 over 5. And now I'm going to divide both sides by 6. So if I divide that by 6, I'll get x giving me 12 over 5. Okay? But now, if x is 12 over 5, and then x is equal to y, it means that y is also 12 over 5. So the question was saying that we should look for the coordinates. Okay, so let's write it. Therefore, the coordinate would be 12 over 5, 12 over 5. All right, good. So this is how to approach a question like this. Let's go to question number 2. Before we continue, I need to help you understand where these particular questions are coming from. So these are actually Cambridge questions that I took from year 2020, year 2019, 2018, and a few from 2015. Okay, so I do not have 2017 questions as part of this. It's the current ones, 2020, 2019, and 2018, and then some parts of 2015, because I needed that to show you something. Okay, question 2 says that you see, this is really important. You do not want to do accurate drawing here. They want you to solve the thing, okay, to get the answer that they want. Now it says that the points A and B, these are the coordinates. So we should do what? Find the equation of the line. All right, that equation of the line is the perpendicular bisector of line what? AB. All right, it's similar to the one that we solved. So if this is A, this is B, then we are looking for this particular equation of the line, okay? The one dividing line AB into 2. That means that we need to know what this point is, because to find the equation of a line, you need a gradient and a point. Okay, so let's start with the midpoint. So the midpoint of line AB would be 4 plus 12 over 2, and then you have 3 minus 7 over 2. That will give you, that's 16 divided by 2, that's 8, that's negative 2, right? Okay, so we are looking at negative 2 and then 8. Okay. Then the next thing that we want to do is to find the gradient of line AB. Gradient of AB will give us negative 7 minus 3 over 12 minus 4. That would be negative 10 over 8, right? Okay, sure. And then when we simplify, we are going to have negative 5 over 4. All right, so once we have the gradient of line AB, we can find the gradient of the perpendicular, right? So gradient of the perpendicular line, you can just do this, will be equal to negative 1 over the gradient that you just found. And this will give you, let me use this to divide that. Okay, so this will give you, let's say 4 over 5, right? Good. So we have a point on this particular line, and that point is what we just found 8, negative 2. We have the gradient, so we are good to go. So we can confidently find the equation of the line. So you can also use y minus y1, right? But the y1 in this case is negative 2. So y minus minus 2 is equal to the gradient, which is 4 over 5 into bracket x minus 8. And this will give you y plus 2, right? But hold on. So this would be 4 over 5x. And then this is 32 over what? 5, right? Good. Then this 2 here will be plus 2. Okay, so I'm going to move it to this part. So that's minus 2. So I'm going to have y is equal to 4 over 5. All right, x. Then let me put the thing on the calculator and see what we will get. So that's negative 32 over 5 minus 2, right? Okay, that will give us negative 42 over 5. And then we are good to go. So this is the equation of the perpendicular bisector that they wanted us to find. All right. Now, let me erase part of this. I don't want it to worry us in our next question. Question number 3 says that variables x and y are such that when you plot this against this, a straight line is obtained. Okay, this straight line is passing through 2 points. All right, so if it's a straight line that has been obtained, then we can write it as big Y is equal to m big X plus c. Now the reason why I'm doing this is to differentiate between the variables x and y that they gave us. Okay, all right, so if this is a straight line, it's of this form, so we can find the gradient, which will be 34 minus 9 over 3 minus 0.5, and that gradient is going to be, what would the calculator say? 34 minus 9 over 3 minus 0.5, giving us 10. Okay, so according to the calculator, the gradient is 10. Okay, now the next thing that we want to do is to find the value of c. Okay, so let's choose one of the points. Maybe let's use 34 and then 3. So y is 34. We have the gradient of 10. X is 3 plus c. So that would mean that we have 34 minus 30 equals c. So c is definitely 4. All right, that means that this equation that we have here changes to become big Y is equal to 10 big X plus 4. All right, great. So the next thing we want to do is, what did they plot? Well, according to the question, they plotted this against that. So your big Y has a definition, and its definition is the fourth root of Y. The fourth root of Y. And then our big X has a definition. That definition is 1 over small x. Now, plus 4. What is the question asking of us to do? If you consider what they wrote here, all right, they said that find y as a function of x. So they want you to make y the subject. All right, if that's the case, and the fourth root, so you can just take the fourth exponent of both sides, okay, and that would make sure that this particular 4 will take up the fourth root. So you have y is equal to 10 over x plus 4 all raised to the power 4. You do not have to expand this, okay? Just leave it like that. They said make y the subject. You've made y the subject, so just move on. All right, okay, let's look at question number 4. Question 4 says, do not do any accurate drawing here. They want you to solve the thing yourself, so let's just solve it. All right, so question 4 says that we should says the points a, b, these are the points, the equation of the line L. Okay, so the equation of the line L, the perpendicular bisector of line AB. Okay, so line the L here is a perpendicular bisector, and they have solved it for us. Okay, now this line is parallel to AB, okay, which passes through this point. all right, and then it intersects this line L that we just found, or we didn't find, they actually gave it to us at point C. So what they want us to do is to find the coordinate of point C. Okay, so what are the key words here? What they said that the line parallel, okay, the line parallel to AB, which passes through this point, is intersecting line L. So at the end of the day, we need to find the equation of the line parallel to AB. Okay. Now, if there's a line parallel to AB, it means that that line's gradient and the gradient of AB are the same. Okay. So we can say that gradient of AB, all right, gradient of AB will be equal to -7 minus 3 over 12 minus 4, giving us -10 over 8, right? Which is -5 over 4. Okay, now they said that there is a line, okay, which is parallel to AB. So like I said, it will have the same gradient. So that parallel line, all right, that parallel line will have its gradient to be also -5 over 4. Okay, all right, so now we can find the equation of that line because we know the gradient and then that line passes through a point, so we are good to go. So we can have y minus 5 is equal to the gradient that we have into bracket x, it's y minus 12 because that's the y coordinate, right? Okay, so then x minus 5. All right, so we can have y is equal to -5. Should I just multiply 3 by 4? Maybe that would be cool, right? I don't have to complicate the maths. So if I multiply 3 by 4, I have 4y minus 48 is equal to -5x plus 25. All right, so I can have 4y plus 5x is equal to 25 plus 48. I'll tell you why I'm doing it this way in a moment's time. So I have 25 plus 48 giving me 73. So this is actually equation number 1. And then we have this as our equation number 2 because they said that this particular line that we are talking about is intersecting the line L. Okay, and that is the line L. Okay, so the next thing that we want to do is to solve these two simultaneously. All right, now I want to use elimination method to solve. That's why I left my answer in this particular form. So if I take equation 2, I can multiply 3 by 5. So I have 5y, all right, is equal to 4x minus 42. So I can just have 5y minus 4x is equal to -42. All right, and then I'll bring the equation. So this particular equation 2. So I can bring the equation 1 beneath it, which is 4y plus 5x is equal to 73. Okay, I call this one. This is actually the equation 1. Okay, so if I decide to maybe multiply equation 2 by 4 and then equation 1 by 5, then I'm going to have equation. So this is by 4. I'm going to have 20y minus 16x is equal to -42 times 4. That is -168. And then the second equation, I said I'm going to multiply that by 5. So I have 20y plus 25x is equal to 73. 73 times 5, that is 365. 365. Then I can subtract these two equations. Okay, so if I subtract, then I'm going to, the y's will be 0, and I'm going to have -16, okay, minus 25, giving me -41. -41x is equal to, then I have -168 minus 365, and that will also give me -533. I divide that by -41, and then I'm getting 13 as the answer. Okay, so right now that I have 13, I can put that into maybe this particular equation, and all right, to find the value of y. So that equation says y is equal to 4 over 5x. So now x is 13 minus 42 over 5. And if you put this on a calculator tells you that the answer is 2. Okay, so now the question was really to find the coordinate of C, and that's their point of intersection. Therefore, C will be 13, comma 2, and then you are done. All right, so let me zoom out a little bit for you to see how the whole thing is supposed to go. So you first need to, since it's a parallel line, you just have to find the gradient of line AB. All right, use that gradient and then use a point that it goes through to form an equation of a curve, of a line. Now, since that line that we have just found intersects the line that was given, you have to solve the two simultaneously, and the values of x and y are the coordinates of their point of intersection. Okay, now let's move on to question number 5. Question 5 says that okay, so we have this particular line here. Let me use a bright color. All right, this line is tangent to this curve at this point. So what do they want? They said that this tangent, okay, intersects the x-axis at P and then the y-axis at Q. So we should find the length of PQ. Well, first, let's start by arguing that what happens on the x-axis. We know that y is 0. Now, they said this tangent. Now, that is an important claim. This tangent. Which one is the tangent? Well, this is the tangent. So let's write that tangent down. So we have 2x minus y is equal to pi on 4 minus 4. Now, they said that this particular tangent intersects the x-axis at P. So the y value there is 0. So we have 2x minus 0 is equal to pi on 4 minus 4. So basically, x will be equal to pi over, that's 8, right, minus 2, okay? So this is what we have, all right? So P is basically pi over 8 minus 2, comma 0, okay? Because the y component is 0. And now, this curve also meets the y-axis at Q. But what happens at the y-axis is 0. So you have 2x, so that's 2 into bracket 0, minus y is equal to pi on 4 minus 4. So basically you have y is equal to 4 minus pi on 4. All right, so point Q will give you 0 and then 4 minus pi on, pi on 4. All right, so the next thing that you want to do is to find the length of it. So you know the formula would be the difference in the x component, that will be pi over 8 minus 2 minus 0 all square, plus the difference between the y component, and that will be 0 minus this minus that all square, okay? And now if you put this in the calculator, you should get 3.59, all right? And that is the distance between these two. So when you see the question, do not panic. The funny thing is that this particular thing here did not really have any effect on the question. They brought it there to confuse you, all right? So when you see something in a question, do not panic, read it, because that's why they made use of this particular phrase here, that this tangent, because they want you to know that use the tangent to work and not the curve itself, okay? All right, now let's look at question number 6. Question number 6 says that we have when this thing is plotted against x, all right, a straight line is obtained passing through these 2 points. The fact that a straight line is obtained, just get that formula for the straight line, y equals mx plus c, but it should be big Y and big X, differentiated from this particular small y and small x that you are given, and then you can go ahead and find a gradient, which will be 20 minus 12 over 3 minus 5, giving you 8 minus 8 over negative 2, giving you negative 4. right? Okay, cool. So now that we have found the gradient, the next thing that we want to do is to find the C. So choose any of the points. Maybe we are going to work with 5, 12. So that means that y is 12, x will be 5, plus C. Okay, it's not 8, sorry, that's 5. All right, so we are going to have 12 plus 20 is equal to C, C giving us 32, okay? Now, so that means that our big Y is equal to gradient, we got negative 4 big X plus 32, okay? So right now, well, all that we have to do is to know what the value of Y is and what the value of big X is. So big Y is this one and then big X is that one. So we can just rewrite it as log y square is equal to negative 4x plus 32. All right, but what is the question saying? The question says that this is it, find y in terms of x, and then we should leave our answer in this form. So we need to find y, not just log y square. Okay, so we want to make y the subject. Well, for every log on its own like that, it means that it's base 10. Okay, so that means that y square is basically 10 negative 4x plus 32. I hope you know how to change from log to exponential and then from exponential back to log. It's really, really important here. And then the next thing that you want to do is to take the square root of that, okay? Since it's y square, you can just take the square root, or just you can also decide to raise everything to the power half, which is cool. All right, so you have y is equal to 10 raised to the power, that will give you negative 2x plus 16, okay? All right, that's cool. Because they want us to write it in this particular form, so we leave it here. We don't do any other thing again, because this is exactly the form that they wanted us to leave the answer in. All right, okay. The next thing that they want us to do is question 7. Oh God, I hate these particular questions because there is always going to be a graph that I'm supposed to work on, and I don't like graph sheets. Yeah, anyways, I've been honest with you. But that doesn't mean that we can solve it. We can do it, just that it takes time. That's why I hate it. All right, so they said that this is a table. The table shows the values of the variables x and y such that this thing has this blah, blah, blah. Okay, they said that draw a straight line, all right, to show this relationship. So once they want us to draw a straight line, right, from this particular relationship, you can get a straight line from it. This particular relationship, this is s squared. Right, so what you want to do is to just take the log of both sides. So you have log y is equal to log into bracket ab x squared. All right, then you apply the laws of logarithm on it when the multiplication law. So you have log a plus log b x squared. All right, and then you apply the power rule of logarithm on it. So that means that that particular thing will become x squared, all right, log b. You can decide to rearrange it well so that you have log y is equal to log, I can just write it as what is it? I can just write it as s squared log b plus log a. Right, this is actually in a straight line because this is like you writing some mx plus c, okay, where this is your c, this is your y, and then the gradient is log b, all right, and then the x squared is the x, okay? So this is actually in a straight line. All right, so basically in exam you don't have to show them that it's in a straight line. Once you get it in this particular format, let me use maybe red, right, you can leave it like this, but I mean bringing this thing there, it's not really necessary, okay? All right, so that's being said, it means that the graph that we are going to plot is, you know, the graphs are basically y against x, right? So this is like this log y is against x squared. That's what you are going to work on. So let's sabotage this particular table and then get the right things down. So we have this, then we have this guy, then we have this guy. Okay, so let's divide it. Okay, so we have x squared. Let's use black. We have x squared, and then we have log y, right? Log y. Okay. All right. So our x values, I think we can get them easily because 1 square is still 1. 1.5 square will give us 2.25. And then 2 square is 4. 2.5 square, 2.5 times 2.5. That will give us 6.25. And then 3 square is 9. Let me make sure that I have 1, 2, 3, 4, 5. And this is 1, 2, 3, 4, 5. Yes, I've captured everything. Right. So the next thing that we want to do is to work on the log y. So we start with log 6. So log 6 will give us 0.078. I'll use the 2 decimal places. And then the next one is log 14.3, and that will give us 1.16. The next one is log 48, right? Okay, so log 48 will give us 1.68. Followed by log 228, and log 228 is 2.26. All right, and finally we have log 1536, and that will give us 3.19. Okay, basically what I'm going to use to sketch will be 0.8, 1.1, 1.2, okay, 1.7, 2.4, and then 3.2. All right, I'm going to use 2 decimal places to sketch, okay? All right. So the next thing that we want to do is to go there and then sketch. So let's look at the x-axis. The x-axis is now called x squared, and then the y-axis is now called log y. These are things that Cambridge will look at and then would score the results for you. Now we have 1, 2, 3, 4, 5. Okay, 5 slots, and the highest is 9. So we can say if we do 2, 4, 6, 8, 10, that will be okay, right? Okay, and then the y, the highest is 3, so we can make it up to 4. So we can say this is 1, this is 2, this is 3, this is 4. All right, I don't think we can make any nice magic here. Hold on, if I make this as 1 and I make this as 2, this is as 3, some of them is more than 3, great, so that wouldn't work that much, right? Okay, so I mean, this is cool. So the next thing that we need to do is to plot these things. So the first one is, let me see how many tiny boxes are here. This is a skill that you need to cultivate. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 tiny boxes give you 1. So that means that each small tiny box is 0.1. Okay, you need to know that. Okay, so 0.1. Good. So with the 0.8, that will be like somewhere here, right? Somewhere here will be 0.8, and now we are plotting 0.8 against 1 here. So that should be, let me use maybe blue. 0.8 is here against 1, will be somewhere here. All right, then we erase this part that we do not need. All right, and then the next one is 2.25, okay, against 1.2. So 1.2 will be somewhere here. 1.2, is it? Good, somewhere here. Okay, so on this line is the 1.2 line, and then we are working against 0.1. 0.25. Okay, so like I said, I hate this, it shouldn't be news to you guys anymore. Anyways, on this axis, okay, on the x-axis, each small box is actually 0.2. So if this is 2, then this is 0. If this is 2, then this is let me see, this would be 3 here, right? Okay, so if I have 2.25 divided by 0.2, I'm looking at about 11 and quarter boxes. So this is about 10 boxes. So this particular box making 11, so almost in the middle of that should be here. I can trace it up. So to meet it somewhere here. All right, then I'll clean all these things. We don't need them. All right, okay. So we have something like this. Then the next thing that happens is we are plotting 4 against 1.68. That's about 1.7. Okay, so the 1.7 line, this 1.5, 1.6, 1.7 is here. Okay, we are plotting that against number 4, so that will be somewhere here. So now we can erase these things, we don't need them. Then the next one that we are plotting is from 6.25. So we can just do 6.25 divided by 0.2. So that we are looking at about 31 and a quarter boxes. So this is 10, this is 20, this is 30. So this is 31. So then a quarter, that will be somewhere in the middle here. Okay, and we are plotting that against what value? Against 2.4. So 2.4 will be, let me use blue. So 2.1, 2.3, 2.1, 2.2, 2.3, 2.4 is here. Okay, so these two will meet somewhere here, right? Great. All right, so let's deepen it, and then let's get rid of the other things. Okay. All right, so the next thing that we do is to plot 9 against 3 point something. So this is basically 9. Okay, so 9 against 3.2 basically. So 3.2 is somewhere here. So they are meeting right there. So we can get rid of this. Okay, and also get rid of that. All right. Oh. Okay. So now that we are done, we need to draw a straight line. So we just hold on like this. I can use maybe a different color to bring the shape out. Okay, so that's a straight line going through all the points. Okay, so that's how to go about it for 4 marks. Yeah, even though it has a lot of marks, truth is I hate doing this because it wastes time. I can waste my, like, well, maybe I'm slow, but it will take about 5 minutes or 10 minutes. I don't know. I don't like it. Anyways, the B says that use your graph to find the values of A and B. How do you really do that? Well, remember that I'm not going to do this thing again. I think I can just copy it. Let's copy something from here. Okay, and then paste it right here. So let me clean some of the things that came with it. So remember, we were given some y equals something, and then we were able to illustrate that it becomes this. Okay, so they gave us y equals ab x to the power 2, right? And then we got this thing from it. Okay, now this thing here is the gradient. Okay, so let's get the gradient. Now all that you need will be 2 points. Don't go back to the graph and waste your time to read it off. No, just come back to your table, okay, this particular table, and then choose any 2 points, okay? So I can just choose maybe 6. Let me write it here and later on copy it. So maybe I'm choosing 6.25 and then 2.36, all right? And I'm also choosing 9 with 3.19. All right, so I'm going to copy these 2 points to help me find the gradient. So I'll paste them here. So these are the points I'm going to use to find the gradient. So I can see that gradient is equal to, then I can have 3.19 minus 2.36 over, and I can have 9 minus 6.25. I can put everything on a calculator. 3.19 minus 2.36, and then I have 9 minus 6.25. And according to the calculator, my gradient is giving me 0.301 something. So I'll just keep it at 0.30, right? But we can see that log B is the gradient, and the gradient is 0.3, okay? Then you can find B to be, there's a 10 here. Like I said earlier, that if they don't write anything, there's a 10 here. So you can confidently write B is equal to 10 to the power 0.3, all right? And that basically means, I'm putting on calculator, let's see what happens. 10 to the power 0.3, calculator says the answer is basically 2. Okay, so you have found the B, but you have to find A, all right? So if you have big X, and then you have the gradient, big Y, gradient is 0.3, you have big X plus C. Now that C here, all right, where is it? Let me use maybe this color. This particular C here corresponds to the log A. Okay, so let's find C. If we know C, we can find log A. We have 2 points here. Let's use one of them to help us out. So that means that we have 2.36 is equal to 0.3 into bracket 0.6.25 plus C. So from here, you can just find C, and that will be 2.36 minus 0.3 into bracket 6.25. And from the calculator, C is basically 0.485. Okay, now I know that I've made this in a mess, but bear with me. So we know from here, let's come here, we know that C is log A, right? So log A is equal to 0.485, and there's a 10 here. Okay, so A is basically 10 to the power 0.485. So 10 to the power, my answer would be 3.05 going, so I'll just keep it at 3.0. So A is 3.0. That means that A is 3 and then B is 2. Okay, and then I'm done. So this is how to go about it. C says that we should look for estimate the value of X when Y is 100. Remember that the whole thing was Y is equal to ABX squared. Okay, so we know our A, we know our B. A happens to be 3, B happens to be 2. Okay, and then we can have our X squared here. Now they have given us Y to be 100, so we can just put 100 there. We have 3 into bracket 2x squared. All right, so we can divide by 3. We can have 100 over 3 is equal to 2. This thing. Then you can take the log of both sides. Okay, so you are going to have log 100 over 3 is equal to log 2 to the power x squared. So that will give you log 100 over 3 is equal to x squared log 2. So x squared is equal to log 100 over 3 divided by log 2. Okay, now the next thing that you want to do is to take the square root of that. Okay, so you have x is equal to the square root of log 100 over 3 all over log 2. Okay, so let's put that whole thing on the calculator and then see the value of x. So log 100 over 3 and then divided by log 2. According to my calculator, my answer is 2.25. Okay, so that's how to go about it. Now question number 8. Question 8, I think it's the same story, just that this was a graph, but I think we've done something similar like this. So I'm tempted to leave it for you guys, or I should just do it anyways. All right. I don't know. Should we? Okay, I think we've done something similar because it's a straight line, and then you are going to just need to have to find the gradient, and you'll be good to go. So I don't know. I'll skip it. You can do it. All right. Then question 9. Okay, question 9 has E in it, so I'll do that. All right. So this is plotted against that. A straight line is formed passing through these points. So if the straight line has been formed, then we just need to have it in this format. Okay, question says find y in terms of x. Okay, so I'll do the calculation, everything here. All right, so I can have my gradient as 8 minus 20 over 4 minus 2. That would give me negative 12 over 2. That will give me negative 6. Okay, so once I have the gradient, I'm good to go. All right, so I can find my c if I use maybe the 0.48. Okay, so 8 will be equal to negative 6 into bracket 4 plus c. So c will be equal to 8 plus what is that? 4 times, that's 24, right? Good. So giving me 32, so it's 32. So that means that my big Y is equal to negative 6 big X plus 32. All right. But if you look at the question that they gave us, they changed a few things because they said that Y, your Y is actually e to the power y, and then your x is that. So that means e to the power y is equal to negative 6 times 1 over x, and then plus 32. They want you to make y the subject, so what you have to do is to basically take the length of both sides. But before I do that, I want to rewrite this thing well. Maybe 32 minus 6 over x looks nice, right? Yeah. So I can take the length of both sides, so that I have y is equal to length 32 minus 6 over x. I think this looks pretty nice. Okay. All right. Then they said that hence find the positive values of y when y is defined. Well, if we have y is equal to ln 32 minus 6 over this thing, well, a ln is only defined when the inner function here is greater than 0. Okay. Therefore, what you want to do is to equate sin 32 minus this thing greater than 0, and then you solve for x. Okay, so you can just multiply 3 by x, have 32, x minus 6 is greater than 0. So x will be equal to 36, 6 over 32, right? Something like that. And if you simplify that, calculator tells you that your answer should basically look like 3 over 16. Yeah, great. All right, then they said I find the exact value of y when x is 3. Okay, so just write y is equal to ln into bracket 32 minus 6 over 3, and that would be 2, so ln 30 basically. So y is equal to ln 30. Okay, right, so let's solve the question D. It says that we should find the exact, all right, the exact value Okay, so what we want to do is that already we know that y is definitely ln 32 minus 6 over x. Okay, now we are told that y is 2, so that means that we can write this thing down. All right, so the next thing we want to do is to take the e of both sides. So this is exactly what we are going to get. Okay, right, now the next thing that we get will be e to the power 2 is equal to 32 minus 6 over x. Okay, all right. Okay, so the next thing that you want to do is probably move the, okay, so let's do some double swap. Okay, bring the x on the left. So we are going to have 6 over x is equal to 32 minus e to the power 2. Okay, so that means that x is basically 1 over 32 minus e to the power 2. Okay, and then we multiply both by 6, so the 6 will be up here. All right, so basically this is how we want to go about it. I had to do some weird maths there to get there. If not, you have to go through the steps. I'm just feeling lazy right now. Okay, now the next thing that you want to do is that they said question 10, right? Okay, what makes this question nice? That do we find area? No. All right, I want one of the questions that would ask us to find the area of a particular, okay, something like that. Find the area. Okay, so this is good. I think we should give this a try. All right, so the questions that I'm skipping, you can give it a try on your own. So question 11, it says that the points A and B have these coordinates, and then there's a line that's having this equation. Okay, we've got that. It says that the gradient of line AB is 1/3, right? Okay, so we should find the value of this. Right, so let's get this point down, because if I do this, this point is going away. So let me just write this quickly. P3 against 1/4, and then we can maybe copy it. Okay, bring it here, and then squeeze it small so that we can work with it. Okay, so gradient is basically going to be 4 minus 3 over 1 minus p, and that is equal to 1/3. That's what the question is telling us. So that means we have 1 over 1 minus p is equal to 1/3, right? So that means 3 is equal to p minus 1. P will definitely be 1 minus 3, giving us -2. So p is -2. Okay, at least according to my calculation. You can verify that for me later on. Okay, now says that show that L, but what is L? Well, we got L to be 3x plus y equals 2. That's what the question gave us, so we can just copy this and go and use it down there. So this particularly L. So show that L is perpendicular bisector, all right, bisector of AB. Okay, so what does that mean? That it means that, well, if this is line AB, okay, they want you to show that this L bisect this particular line. Okay, so if that is the case, then there are two things that you need to do. All right, number one, you can use the gradient, can show that the gradient of this perpendicular bisector, all right, and then this line, the product of their gradients. Okay, so m1 times m2 will give you -1. Okay, that's the number one thing you can do. Or number two, you can show that the midpoint here, okay, the midpoint here satisfies the equation of the perpendicular bisector. Okay, so you can use any of this to show it. Right, so now let's start with probably the gradient approach, right? Cool. So I'm not saying that do both, but if you know both, it's cool. So in the exam, if one is not working, well, you can try the other one out. So we have this. That means that the gradient will be so gradient of line L, let me call it m1, is maybe -3. Okay, and gradient of line AB, they told us that gradient of line AB is what, 1/3. already here. So if it is a perpendicular, show that it's perpendicular bisector. Oh, okay. If it's about perpendicular bisector, then it doesn't matter whether their gradient, the multiplication of their gradient is equal to -1, because every perpendicular will give you this. So if it's a bisector, then let's work with the midpoint, okay? All right. Okay. So the midpoint, this is actually 1. Okay, so midpoint of AB would be, now that we know P, that would be -2 plus 1 over 2, okay, because we know those points here. That's what I'm using. And then, so I've added the x components. So now y will be this plus that over 2. I'm giving us, this -½ all right, working with 7 over 2. All right, so this is the midpoint. Like I said, if we have A and B, this line AB, and then we have our perpendicular bisector. All right, so this midpoint here is definitely going to lie on the perpendicular line. Okay, so this point that we have found should satisfy this equation. Okay, so how do we prove that? Well, you can put x in there and try to get y. All right, so if you have y, so from here you can change it to -3x plus 2. Okay, so put the x there, which is -½ all right, so you have -3 into bracket -½ plus 2. This should give you 3 over 2 plus 2. And let's see, 3 over 2 plus 2, that gives you indeed 7 over 2. Okay, so once you have shown that, right, this midpoint satisfies this equation, okay, now the next thing that you want to do, so this midpoint that you found, actually the marking scheme will give you 1 mark. If you have been able to prove that it lies on the line, you get another mark, making 2. Okay, but the thing is 3 marks. So you are left with the last one, and that's what I started with earlier. All right, so looking at this line, 3x plus y equals to, you can get the gradient to be what? The gradient, or m1, is -3. Okay, and then for line AB, we also found the gradient to be 1/3. So for, let me call it m2, is 1/3. Now, the next thing we need to do is to prove that m1 times m2 is equal to -1. Okay, and that will be -3 times 1/3. Obviously, that's equal to -1. So this will give you the extra 1 mark, making 3. Okay, so if we are to show that a line is perpendicular to probably a bisector of another line, then there are 3 stages that you have to go through. Find a midpoint, okay? Use the midpoint to show that it lies on the line like this, okay? And then you have to also show that the gradient of line AB times the gradient of the perpendicular bisector should give -1, and you are good to go. All right, C says that given that there's a point C like this, it lies on this line, find the value of Q. All right, but remember that the line L is what the question gave us, which is 3x plus y equals 2, okay? So we have 3x plus y equals 2. Now the x is now the q, so you have 3q plus y, the y is -10, sorry, so plus -10, all right, equals 2. So now you are going to have 3q is equal to 12, right? So q is equal to 4, okay, for 1 mark. All right, so the next thing that we need to do is to find the, how do I call it? The area, all right, the area of the triangle. Okay, so this is what you do. Area is half the absolute of, well, you need some points. The first point is point A, right? Point A is P3, but we already found P to be -2. So point A is -2, 3. And then point B, they gave it to us 1, 4. And then point C is what we just worked on. That's Q -10, but Q is 4. So we have 4 -10. Okay. So now you have negative 2, 3, you have 1, 4, and then you have 4, negative 10. Now, the point that started, which is this point, should be the point that ends, okay? So you have negative 2, 3. Keep that in mind. It's very important. Okay, then you do the downward diagonal first, all right? So this times this times this times that. When you finish, then we do the other side. Okay, so this is going to give us half absolute into bracket negative 8 minus 10 plus what? 12, okay? Then plus, then now we have to do the upward diagonal, okay? And then this, so now that will give us 3 plus 16 plus 20, right? Yeah. Okay. All right. So now we are going to have half into bracket. We have negative 8 here. And then coming from this side, we are going to get 20 plus 16 plus 3. That will give us 39. So that means that we have half of absolute 31. And absolute 31 is basically 31. So we have half into 31. And that will be what? 31 divided by 2? We are getting 19.5, right? Sure. Cool. All right. Have we made a mistake somewhere? Nope. Okay. So this is 8. This and that is 8. I just feel like we've made a mistake somewhere. This is 10. This is 12. And that gave us our negative 8 minus 10 plus 12. Oh, that is negative 14. I knew it. I just felt that we've made a mistake somewhere. So this should have been negative 14, okay? All right, so negative 14. Am I right though? No. It's negative 8 minus 10 plus 12, right? That's negative 6. Negative 6. Sorry, guys. Okay, so plus 39, right? Okay. And will this give us, this is also 3, 4, 4, 16, and that would be 20, right? Sure. So that would be that's 19, and then the 20 giving us 39. And so that would be 33, right? Okay. 33. Then half of 33. All right. That would be 16.5, right? Okay. That's 16.5. All right. And then we are good to go. Okay. So what else do we do? This particular question also comes with area. Okay. So you use that same plan to find the area. Well, let's solve this as the last question for today. Okay, this question really looks similar to one of the questions that we solved up there. I remember coming across that, so I would let it go. And then we can solve this one and call it a day, right? Yeah, so that you can do the rest later on your own. Okay, so question number 15 says that trees in certain forests are dying because of an unknown virus. I hope it's not coronavirus. The relationship has been given as this. We should transform this relationship into a straight line form. Okay, so you have n is equal to a, b, negative t. So take the log of both sides, and then you are going to have log a, b power negative t. So this is going to give you log n is equal to log a plus log b negative t. Finally, you are going to have log a, all right, minus t log b, all right? And this is basically y is equal to, this is your mx, okay, plus c. All right, okay. So what do? They said that given the data, we should get a straight line. So now it's like we are plotting this against negative t. Okay, but if you look at it, t is years, and years can't be negative. So even though the question would want us to use negative t, we are not really going to use negative t because t can't be negative. Okay, all right. So if it wasn't if t wasn't years but something else, maybe temperature, then we could have used the negative. All right, so keep that in mind. Right, so the next thing that we want to do is to get the plot for log n. So we are going to plot log n against t. All right. Okay, so log n, that means that for the 2000, you are going to get, I'm going to use two decimal places, that's 3.30. I'm going to get 3.11, 2.95. I'm going to get 2.77, yeah, then 2.60, and then 2.41, right? Okay, now even though I'm using two decimal places on my work, I'm actually going to use one decimal place. Okay, I don't want headache. Okay, so I have 1 up to 6 on the x-axis, and now my x-axis is called t, right? And then my y-axis is called log n. All right, and that is from 3 all the way to, actually the lowest is this, right, all the way to 3.3. So if I move as maybe this is 1, 2, 3, 4, that would be cool, right? Yeah. And then for the t-axis, I have 1 to 6, so I can do 2, 4, 6. Okay, and then that means that this is 1, right? Because this 1, 2, 3, 4, 5. So that's 1, 1, 2, 3, 4, 5. This would be 3. 1, 2, 3, 4, 5. This would be 5. Okay. All right. So I have divided everything nicely like that. It's good to really know your demarcations well. The advantage of having a screen is that you can zoom in and zoom out and things, but in exam room you cannot zoom, so be careful there when you are plotting. Okay, so now we plot 1 against what, 3.3. Okay, so now what you want to do is to find the value of one tiny box on the this particular axis. Okay, and now when you can have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes give you one value, so it means that each small box over here is 0.1, or you can just do 1 divided by 10, and that will tell you that each tiny box is 0.1. Now on this axis you have 10, and that gives you 2, right? So each value is just 2 divided by 10, giving you 0.2, right? Okay, all right. So the next thing that we want to do is that you want to know the number of boxes that will satisfy 3.3. Okay, so but you don't have to worry yourself like that, since each box is just 0.1. You can come to where the 3 is, and this will be 3.1, 3.2, 3.3 over here. Okay, right, then 3.3 against 1, but 1 is right here, so we can just trace it up, and then we'll get it here. Okay, then you just erase this stuff because you don't need that in your worksheet. Okay, then this is there. All right, then the next thing that you want to do is to get 2 against 3.11. So this is 2 all the way against 3.11. So that would be like, this is 3.1, all right, but 1, so maybe yeah, just almost getting to the middle of it. That'll be cool. So 3.11 maybe right here. Then the next thing is we are plotting 3 against 2.95. Okay, so 2.95 will be really close to 3, but it's not 3. This is 3, so 2.95 is really close. All right, so something like here. Okay, then you see it's not really, it's a graph work, so you are not really going to draw to the best. I mean, maybe the perfect drawing. No, you're not going to get that. All right, then the next thing is 4 against what, 2.77. So I'm just going to use 2.8 in my head. So 4 against 2.8. So this is 2.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, somewhere here. All right, and then 4 is on this line, so I'm just looking at somewhere here. All right, and then the next is 5 against 2.6. So that is cooler because it's easier to get. So this is 2.1, 2.1, 0.2, 0.3, 0.4, 0.5, 0.6 is right here. It's easier. So while you can see right now that we are getting a straight line, okay? And then number 6 is 2.41. So that's 6. So this is number 6. So 2.1, 2.2, 2.3, 2.4. 41 is just almost at 2.4, right? You cannot get as that accurate. I mean, this is something that we are just trying to sketch, you know. If you join the curve like this, like that, try to let it go through or something like this. All right, and then you are good to go. Then what do they want? So this is for 3 marks, okay? I mean, I don't know. I don't like to start graph work early because it just takes my time, but it's up to you. Now we want to find estimate the values of A and B, okay? But now remember that this thing is what we got this whole thing from, okay? So if I were to write it right here, maybe y, sorry, yeah, why not? Let me write it as y equals mx plus c, all right? And that was log, this is equal to negative t log b plus log a, right? When we were given something like this and then we worked on it, this is what we got, remember? Okay, so that's exactly what we have here. All right, okay, so sure, good. All right, so now if you compare, then you can say that, well, the gradient is the m, okay? And that m goes with, we plotted log n against t. So that makes the m as a gradient, okay? So m is basically negative log b. That's the entire thing, okay? All right, so we need a gradient. Even though they have stated use your graph, okay? Don't waste your time to come and worry yourself how to read these values again, because you got the graph from this table, right? So get two numbers, maybe 1 against this, and then I'll also work with maybe 5, 5, 2 point this. I mean, it's okay. You can choose any 2 numbers, basically. Okay, let me copy this. Go and use it down there. I should just maybe cut it rather. Okay, and then we put it here so we can use it. So the gradient m would be 3.30 minus 2.60 over 1 minus 5. That will give us, if you put it on calculator, what do we get? 3.30 minus 2.60 divided by negative 4, right? So that will give us negative 0.175. Okay, so we can say that negative log b is equal to negative 0.175. All right, now know that the base here is 10, so b will be equal to, first let's divide through by negative 1, okay, to get rid of the negative on both sides. So negative 1, that means that now we are working with log b base 10 equals 0.175. So b is basically 10 to the power 0.175, which is about 1.5. Okay, right. Then how do we find a? Well, a is the same as the c gives us log a. Okay, so what you want to do at this stage is that take your y equals mx plus c. You found m to be what? Negative 0.175, okay, plus c, x plus c. So now we can use this point to help us to find the value of c. So we have 3.30 is equal to negative 0.175. X value is 1 plus C. All right, so C is basically 3.30. All right, 3.30 plus 0.175. So C is 3.475. Okay, but this C is also equal to the log A. All right, this particular argument is the constant there. All right, so log A is equal to 3 point this. Remember that log A is also base 10, so log this will be 10 to the power 3 point this whole thing. Put it on a calculator, 10 to the power that, and you will get, according to the calculator, you will get 2985, but three significant figures will be 29, maybe 29 90, right? Okay, so that is how to basically go about it. All right, so the next thing is, if the trees continue to die the same way, find the number of trees that will survive after 10 years. Well, you have calculated your value for both A and B already, so that means that this particular function that they gave you, n is equal to ab t to the power negative b to the power negative t. So n a b negative t. You know what the value of A is, you know what the value of B is, so you can just work with n will be equal to A, which is, maybe we should use the unapproximated one, okay? And then B, we got 1.5 raised to the power. Find the number of this after 10 years, so T is 10, all right? And then you put it on a calculator. So you have 2985 times 1.5 to the power negative 10. Okay, and that will give you roughly 51.76. So can we say that maybe since it's trees, we don't have decimal trees, so maybe about 52, right? Okay. All right, but wait, hold on. The thing is, if I write 52, we are committing a big error. These are trees, okay? And the trees that is available at this case are actually 51. You cannot round up trees and magically get one, approximate the decimal, the half of a tree to become a full tree. Okay, so just leave your answer as 51. It's better that way. All right. Then the next question is, find the number of years taken until there are only 10 surviving. Okay, so now this time around, you have n is equal to 2985 1.5 to the power negative t, right? So now they want you to find the number of years when n is what? 10. So you have 10 is equal to 2985 1.5 to the power negative t. All right, so the next thing you want to do is to divide. So let's say we divide that, and then we have 1.5 to the power negative t, and then we can take the log of both sides, sure, right? All right, so we have log 10 over this is equal to log 1.5 negative t. Okay, so that will give us log 10 2985 is equal to negative t log 1.5. Okay, so you just divide through by negative log 1.5. So t is equal to log 10 over 2985 all divided by negative log 1.5. And you just put it on a calculator at this stage. So log 10 over 2985, and then we have negative log 1.5, and then calculator tells me that you get 14.05. So I can leave it in this form since it's actually years, or I can just say approximately I'm looking at 14 years. All right, and then we are done. Okay, so there's a question here that you can give it a try, and then that's it, right? So I'm tired. I'll leave it at this stage. I will leave the description to the link to this particular worksheet in the description. So check it out, and then while we are solving, you would also solve alongside with us. All right. Thank you for watching. I'm subscribed to the channel for more content. I'll see you next time. Bye for now.